Okay. Today we have a privilege, and I'm saying privilege because I have been looking forward to this session for several months now. We have Dr. Miloš Popović, who is right now a data analyst at Booking.com based in Amsterdam. And he is one of the most popular GIS instructors and trainers online you can find today, but he also is a very highly well-published academic as well. I think you had a Journal of Conflict Resolution piece, or was it Journal of Peace Research? Is it?
Yeah, actually, so it's I have two in JPR. Also, just one more modification. So I forgot to change on my website. I'm now actually a product manager, but still dealing with data. Okay. But that's fine. It's my mistake.
Okay.
Yes. So I used to work in academia. I don't work anymore, but I used to actually work in your area. So international relations, conflict.
Yeah. Exactly. So definitely follow him on Twitter. He has a very popular Twitter page where he shares all of his tutorials. It's one of the most valuable resources on GIS that you can find online. You should also follow his GitHub, where he also shares his instructions, the data, the code. You can all find here. So I will stop share, and I am going to give you sharing permissions, and we can see you very well. We can hear you very well. So you can just start whenever you like.
Well, thanks a lot for the kind intro, Akin. I'm really happy to be here, at least online, and to share with you some of the stuff I've been working on for a long time. Actually, today we're going to do the basics of geospatial analysis and data plotting with R. There's so many other things that we can do, but this is like we need to kick off somewhere, and also like there is probably a difference in skill sets and what actually you already covered with either R or Python. So yeah, the way I envision this is totally hands-on. So I'm not going to have any kind of a PowerPoint presentation and then go through that. I actually just sent you a code, and then based on that code, we're going to cover the areas. And as we go, I'm going to actually also explain what we're actually covering, what is the the added value of what we are doing there, and what are actually some of the libraries that we use, what they mean, some functions, what they achieve. And the way I structure it also is the way I learned R myself, which I started learning, I think was like 9 or 10 years ago. Before that, I used Data, and I had one colleague who was really proficient in R and writing functions, and he told me you should definitely switch to R because Data is very limited. You can't do anything. And then I like to take challenges, so I took his challenge, and it was very painful, especially the ggplot adventure. Super frustrating. The way I approached things was like I had a problem, so I wanted to plot something, and then how do I find functions? How do I build code that allows me to create certain graphs? And then bit by bit, here we are 9 years later. I also expanded all this knowledge into also GIS and data visualization with R. So it's been a long journey, but I do believe that even if you take an unconventional path like I did, so basically just learning by doing, that you can go, you can achieve a lot. And also these days there are a lot of tutorials, not just written, but also YouTube tutorials. I'm also making some of them, so we can also go through them later on just to show you what are some of the advanced topics that you can also cover. But I don't think I need to say anything more about the geospatial analysis with R. It is, I think, the place to be. I know that Python also has, but I never tried it because I was already immersed in R. But I saw examples that Python can also do a lot of cool stuff. So I hope that you installed the libraries. If you didn't, please let me know. These are just some of the basic libraries that exist in R. Actually, tidyverse is like the umbrella library. So I'm just going to share actually my screen so we can go through these things. So hope you can see my screen. Can you? Yeah, perfect.
Yes.
All right, perfect. So the first thing is basically just to load those packages. So I'm not going to write them here. I'm just going to just copy and paste them from what I already did here, because it's a bit of a nuance to do it. I do it all the times in my tutorials, but it's just too much. So first of all, I suggest that you really set your working directory, because we will be downloading one of the files there. It would be super useful that you set it, because then you will know where you downloaded your file. Maybe it sounds obvious, to say that, but it definitely sometimes is not so obvious. So in terms of data, I just want to quickly show you. I don't know if you had a look. So first of all, this is a repo where you can find all my code and some examples, also some text I wrote about today's tutorial. So we'll be using the Uppsala Conflict Data Program's georeferenced event dataset. So if you click here, it's actually going to take you directly to this place where they have all the datasets on the UCDP website. This one is really, I think, one of the best sources on conflict data, the most disaggregated I've ever seen. There are some other ones dealing with also other conflict activities. I think, for example, START dataset. There's also AC-led. But for AC-led, you need to be registered and you need to then log in and then to use their API. This one is still old-fashioned, maybe luckily so, because you can also then download directly what you need. You can also access their code book. I don't know if you had the chance to look at. It's very long, something that UCDP usually does. They make very, very long code books. But for us, what is the most important thing here is that there are different types of conflict that they cover. There are so-called state-based conflicts. So this is basically where two states, two governments clash. Then there is non-state conflict. I'm just going to increase a bit so that you can see. Non-state conflict. So this is where two non-state armed groups also clash. And then you have this one-sided conflicts, which we're going to map today, which is basically just violence against civilians, so who cannot defend, who cannot, strike back at the perpetrators. It has a lot of other information about the conflict, about the actors, as usual, as all academic data sets have, different names of them, which we're not going to use in this short tutorial. We're going to actually focus on conflict in Ukraine and seeing, okay, what are the civilian deaths so far that are based on the 2022 data, because UCDP goes only until the end of the 2022. What is really, really cool about this data set is, for me at least, this part, which provides coordinates on the location of these events, which makes it one of the most disaggregated data sets that exist there. So basically, it goes down sometimes to the level of villages even, which allows you actually a lot of space to do geospatial analysis, a lot of different things, to aggregate this data to different levels, to analyze distances, this and that. So a lot of potential there. It also offers, a place where this actually took place, so the name of it. So you can also aggregate based on the location itself. Of course, one of the things that is also cool, you can filter by the country, which is exactly what we're going to do. So we're just going to take, Ukraine by the name. And then also there's a temporal dimension, so you can see when this event happened, or if it's a prolonged event, you can also see when it ended. And finally, there is a place where they actually record the number of deaths, whether it's civilian deaths or some other actors involved in the conflict. And one of the distinguishing things about dataset is that sometimes they even offer this different estimates. So their best estimates they have based on the resource or sources, low and high estimates also based on the sources. And one also very good thing there, this is very methodologically robust in the sense that it's also triangulated among different sources. So it's a highly recommended if you haven't used UCDP so far. It's a really cool one. Okay, so back to this screen where we have actually the data set itself. Here you have actually several options what you can download. There's even data format and R, but I like to use CSV format. So what I like to do is simply copy this link here. What you can also do, you can also just click on this CSV, and it's actually going to then download to your local drive if you don't feel like you want to do anything in R. But I do suggest that you do things in R, because at some point you won't be able to access data in this way. You will need to go through an API. That's mostly the standard these days. You go through API. So it's really good that you already developed skills of downloading data programmatically in R, unzipping if necessary, and then loading the data set, and then doing some data wrangling directly in R. Okay, so the first thing is then to simply load this. So I copy this URL, which I'm going to call URL, and I'm going to store it here. And then I actually also want to name this file that I'm going to download. You can see here extension is zip, so we're going to download a zip file. So we need to specify that. So let's say we call it UCDP GED, which is the name of the data set, and .zip. Very important to specify here. And then there is in base R something which is called download file, which helps you simply download. Here you need to specify several things. First of all, what is the URL from which you are downloading? We've already done that. That's the first thing. The second thing is the file name that you're going to choose here. So file name, which you've already defined here. And then the mode, which is the binary mode of downloading. And then you can just run this whole thing, which will then download to your drive. It's 25.4 megabytes, which is in a zip format, but when you unzip, of course, it's going to be bigger. So I just want to make sure that this is so far clear, that you managed to do it to download the file. If not, you can just, so again, you can just click on that link on the website and just download it to R. I just want to show you how we can also easily do this in R, and also automate your work. Once you downloaded this, we just are going to actually, just unzip. And again, base R has a, it's just like a very reasonable name, unzip, and then you just specify here what you actually want to unzip. That's your file name. So we're able to do this because we do have actually specified the working directory at the beginning, so we can just operate here with file names, and that's basically it. So once you unzip, we can finally load this into R. Let's call it also UCDP GED. And again, we use base R function, which is read CSV. For those of you who might be wondering where actually I'm working, so this is the VS Code. I don't know if you're working in something else. For usually people work in RStudio if they're working with R. I tried it only once, and then I didn't actually go for it. I used Sublime RPL in a long time as an editor, and now I'm working in this IDA. It's IDE. It's a very, very cool one. Also, like the way it shows things, you can also see here a basic description of every function basically in R. And also all those base functions, they're actually painted in yellow. So that also helps you understand where your packages come from. So we're just gonna, load this file, and if you actually check where it was, downloaded, you will see, this is the name of the dataset. So you can just copy the name from your local drive, you place it here, and the extension is CSV. So that's also important to note. And finally, you should also define here the separator. So CSV files sometimes have commas, or mostly they have comma separators, like in this case. So you should also specify that. Sometimes they have semicolon or something else. So it's worth specifying that. So this tells actually R how to separate columns. In other words. So then we can simply run this and get this data set into R. It's going to take some time, like not too much. Okay, I'm done. I don't know about you. So did you manage to actually load the data set, or do you have any issues so far?
So maybe if so at certain points of this tutorial, I tested the codes and they're working perfectly. Especially in parts where you will be connected to either combining geo data or accessing some sort of API to get the coordinates of the location. It takes about 5 to 6 minutes, so there will be sections of this tutorial where we're going to just like wait for 5 minutes, 6 minutes for R to actually connect to a live API, get the coordinates, and then combine those coordinates with the location names. Let me know how you're doing right now. Can you follow very well? So we get a lot of notes, so apparently they are. So you can just like go ahead. We're using RStudio, but I tested all of your codes on RStudio. They're fine. I mean, no problem.
Cool. Great. So what I like to do when I load a data set into R, I actually like to inspect, like, let's say the first few rows. So for that, you can use this option head. If you want the last few rows, you can also use this option tail and then just pass this name. So we just like quickly inspect this one. Of course, we get a lot of information because, as you saw in the code book, like UCDP has quite a lot of columns. So this is pretty much a mess, but some things that we can see here is, of course, what are the basic, what is the basic information about the conflict, when it happened, where it happened, who were the actors, what is the type of conflict. There's even this huge thing about, the sources that they use. So yeah, it's pretty robust. There's a lot of information. There's also here about, date end and date start. One thing to notice here is the dates is actually in the timestamp format. So which we will actually going to fix, which is going to turn it into a date format. So without these, this part on the hours, minutes, and seconds. And of course, there's this part about civilian deaths that you can see here. One also thing that you can check, what I also like to see is, okay, how big is this data set in terms of the rows? So then you use this n row, which is basically means number of rows. So then if I just expand this, and we can see here, so wow, it has 316K rows, more than that. Yeah, that's quite a lot. But again, because we are going to be working only on the case of Ukraine, it's going to be a much smaller number of data frames. So first things first, let's put some order into this data frame. First of all, let's check actually also the names. The names in this data frame. It's also quite useful, like given that we cannot really see anything from just inspecting the first few rows. So here you can see 49 columns. Then some of them we need, some of them we don't really need. Some of them that we need is, for example, this one, 26 on location. This is going to tell us the name of the location. Then we will need this one, which is 30 on latitude and 31 on longitude. And then what else do we need? We need also date start. So that would be this one, 39. And of course, civilian deaths, 43. The reason why I'm saying these numbers is exactly we're going to be specifying what are the number of columns that we are going to actually take and filter. Also, one thing to check, which we should do right away, is the country name. So that's number 34, because I would like to use here, let's say ISO 2 or ISO 3 code, but I know from my experience with UCDP, they don't use these standard measures. They have some their own codes of countries, which really makes my life difficult. So let's check what are all the names of the country that exist, so that we can know how to filter Ukraine. In other words, is Ukraine, labeled as Ukraine? I mean, sounds silly, but for example, in some cases, like for example, Syrian Arab Republic is the official name, but I don't know if they put that's long name or a short name. So the way to check values of a column, but only unique values, so not to print everything, is using this unique, it's base R function. And then we can just access our data frame, and then search for the countries and see what are the unique names of them. So let's see what are the unique names. There are 124, and Ukraine is indeed Ukraine, so it's 116. So we can definitely use that. All right. Yeah, let's run again this. So let's actually start by creating a new object, which is going to be called just with an extension Ukraine, so UCDP GD Ukraine. And then over here, we can actually build a pipe. For those of you who are not familiar with this NR, it simply means you are continuing your operation on this base one. So you're just adding one step to every modification that you do along the way. So you don't need to create every object at every action. Everything will be passed final. So the final operation and everything preceding that will be passed to this object here. So this is how a pipe looks like with some of the newer versions. Okay, so as we said, we just want to have Ukraine. Luckily for us, that's possible. So here we use the package dplyr from Tidyverse, which is used for data wrangling. Another one that comes from Tidyverse is ggplot2, which we're also going to use. So there's this option called filter. And then here we just specify this country we want is Ukraine. Notice here, I use here this one double equals. So this is when you're using dplyr functions. Or other functions in R where you want to specify something to select or to filter from. So we're going to take Ukraine. Okay, so that's the first thing that we're going to do. The second thing is selecting only those columns that we need for this analysis, because there are 49 columns is just too much. Again, we use dplyr, and it has option select, which allows you, like in SQL, also, selecting columns from the existing data frame. So we said the following. We want, what do we want here? We want number 26. So this is the location. Then we want 30, 31. Okay, so you can also specify like this, because sometimes I don't know the column names or they're too long. So the good thing about dplyr, you can just specify here the number of the column from the data frame that you want to grab. And then if you have one number after another, a cool thing in R, you can use this column to just indicate from to. And then of course you specify comma in between. Then we said 39, I think. Yeah, that's date starts, 39. And then finally, civilian deaths, which is 43. Okay, perhaps at this point we can also check if we did this, correctly. Just run this code, and then we can actually check the head of this object. So let's actually expand this a bit so they can see well. So yeah, I mean, it looks like by the names, judging by the names, I didn't actually include the country here. It seems that it's based on the names of these villages, it's Ukrainian. Yeah. If you really want to check if this is true, you could also, for example, include here the country name. So like just to make sure, but let's trust the filter option here so that we specify everything well. Is everything clear so far? Were you able to kind of filter this?
Let me ask a question.
Just the meaning of if is operator or and greater than. What's the
can you hear us? There are microphones around, but can you hear us?
Yes, there was a question about the operator or greater.
Yeah. What is the function of this operator in this code exactly?
So in the case you are probably asking about the filter, if you want something else, then or
I think the greater than operator. Are you asking that?
Pipe operator.
So I think that is pipe operator, right? It's a kind of
pipe operator.
Yes.
And greater than sign. Yes, that one.
Yes. This is the pipe operator. Yeah. It used to be. So it used to be from different library. It used to be like this. But now we have in base R, we have pipe like this. So you don't need to call any library to, yes, so sorry, this is the pipe, this.
Okay.
So what happens here?
Yeah, we're more familiar with the, you know, the stranger one.
Yeah.
Okay, another question?
I couldn't catch what a unique function does.
Unique function, what is it?
It's this one.
Yes.
Like 5. So
What does it do?
So a unique function, what it does is basically just takes only unique rows from a selected column of a data frame. So here we have time series for countries, right? So we have country and dates, and then something happens. So you have a lot of multiplication of this country value throughout the rows. What it does is just gives you a 1 occurrence per every original row name. Why do you use this? Well, you use this when you want to just gauge what are the values in a certain column that I have. So you don't care about the frequency, let's say, of the occurrence. You just want to see what are the original values. And the reason why I used here this unique is I wanted to see what is the name of, like, how is Ukraine actually labeled? Is it labeled just like Ukraine, or is there something else? Yeah, so that's the meaning of it.
Thank you so much.
Yeah, no problem. So then we can do some other data wrangling things on this data frame. So as I said before, you probably noticed there is like a timestamp formats over there, and we actually don't need timestamps. You probably also saw there are just zeros for this timestamp for some of the selected sample because they don't really record. As far as I know, the hours and the minutes when something occurred in the UCDP. Maybe I'm wrong. So we can just again use dplyr, and there is a function which is called mutate, which you will encounter a lot if you're using the dplyr, which is used for modification and creation actually of new columns. So this is what it does. So we can create something which is called, for example, time. And then there is a function in base R which is called asDates. So this is going to convert that date starts into a date without those those timestamps. And I will show you now how this looks like. So let's run everything again, and then let's simply see this. How this looks like. So here you can see the new column here, time. You see here that it's without this, hours, minutes, and seconds. It's simply year, month, and day. That's it. And then if we also inspect this time, we can also see, so if you use summary, it's going to actually show you some of the, statistical summary for a column that you choose. So for example, for time, if we do this, so what we have here is the following. So minimum is the start date. So it starts in 2014. And then the maximum one is 31st of December, 2022. So this basically means that our data set ends end of 2022. So there's nothing for 2023, unfortunately. But what I would like us to do here is let's just focus on 2022. And we could also probably focus on the time when the Russian invasion started. So that would be 24th of February. So we can just discard anything before that, just to make it kind of a more, limited time, more kind of a reasonable, but also in terms of the size. So we can again build pipe, and for filtering, we can use this dplyr again. So filter, and then this time we want to filter time. Now in R, what is very important is, so we want something that happens on or after 24th of February. It's very important here that you actually declare that you are dealing here with dates. So we need to do again as.dates. And then here we pass a string of that data that we want to filter. So that's 2022, and then followed by month, which is the second month, and then followed by day, which is 24. So what do you understand what we actually did here? Do you follow? Do you know what's going on?
Can you follow what's happening? We have a lot of notes. Yeah, they're very good. They're very good.
Great. I'm really happy about that. Yeah, perfect. Okay, and then this is now a bit long one, but I just want to add one more that we're going to use actually later on. And also it's quite cool to understand how you can work with dates, because I bet that at some point you will need to work with them, and they can be a bit tricky and getting them into proper format. So one of the things that I wanted to show you here is also, okay, how do we actually aggregate dates? Let's say, for example, we want to have months, and then we want to analyze for every month what was the situation with civilian deaths. So we can also create a new column here, which we can call, for example, month year. Well, I call it month year, but because we only have 1 year, it's fine. But sometimes you might have multiple years, and then you really want to have month and year. So the way you do that is the following. You need to declare formats for dates. And that format is the following. So the way it's defined in R is you need this percentage symbol, and then year, this is gonna print the whole year, so basically 2022. If you choose a lowercase, it's only gonna print, you know, 22 or 23, whatever it is. And then it needs to follow actually what we have already in the date. So it goes by dash. So the years are separated from months by dash. And then finally, you just add another percentage symbol, and then M for the month, which is going to also print the month. So that's the first thing. Now, within this formats, what we want to actually, modify or we want to change is that time. So we need to also specify here as dates, time, and then here within this one, what it's going to do is it's going to transform this into a date, but it's already a date, but it's going to give it a different format. And format is going to be year, month. And then finally, you can just wrap this up into a factor so that we can actually work with the categorical column here. So it doesn't stay at the date level. Some of you might ask now, okay, why do we do year, first year and then month? Like you can also do it month, year. That's fine. But I actually noticed once I was doing these transformations that if you actually then convert this whole thing into a factor, so into a categorical column, it's not going to order properly if you do it month, year. It's basically going to follow the month number. So then it's going to put together. So if you have multiple years, in this case, it's going to be fine. But if you have multiple years, it's first going to put January as the first levels, and then going to go to February and then March and etc. So it's not going to be based on the year month. It's going to be based on a month and then year. Let's just quickly run this. I'm going to show you, and then we can see if everything was fine, if you understood what we were doing here. So let's just quickly inspect the first few columns. So this is what we got in terms of month, year. Oh, actually, it didn't convert it. Interesting. It should have converted into factor here. Strange. Let's actually see what's going on. So we did here month, year equals as factor, format, as date, time. Okay, so this is the mistake. This should be separate from this. So as date should be only applied to the time, and then format we provide within this one. Should be fine now. Okay, let's try it again. And then let's see now. Okay, now it's fine. So you see 24th of February was converted into 22 year and then the second month. Are there any questions about this? This is a bit trickier parts in general in our dealing with the dates.
Any questions about the dates? The dates, converting them, manipulating them. I think they have done it. I mean, they're following you really fast, but I think if there are questions, I think there'll be questions like further along the way.
Okay, cool. Then we can finally go and move on to actually plotting something. Usually there's a lot of data, and people think when you're like visualizing things, that it's so smooth, but usually the data is just has to be transformed. So one of the things that I like to do before I dive into ggplot2 is actually create a theme. So this is how things are going to look like on the plot and around the plot. And then we can pass that theme later on to anything that we create. So we can use just like a single theme. So let's do that. And let's create actually a function for that. So let's pass it to function. So I call it theme for the win. And then the way you define functions is like this. And then you open this curly brackets. And within those brackets, you then specify what you actually want to have. So first of all, I like to start with the theme void, which actually removes everything around the plot, like all those grids and all those unnecessary labels. And then I use theme arguments to actually specify some things that I want to keep or some things that I want to change. So one of the things that you can specify, there are many things you can, but I like to start with legends. So legend position on the map. Here you can specify either something descriptive, so sides of the world, top, bottom, right or left, or you can specify the actual location using this. So this would be a list of two values, x, which is a longitude, and y, which is a latitude. So you start with x, and usually these values go from 0 to 1. They can also be negative if you want to push something, to the sides. But the basic logic here to understand is, like in the coordinate system, reference system, so negative values are south and west, and positive are east and north. So if you want to push something, up, you're gonna use, you're gonna increase the value. And also if you want to push down, you're gonna decrease. Anyways, that's something that you can explore on your own. For now, we can just put the legend on the right-hand side. You can also put it, as I said, top, bottom, left, right, whatever you wish. You can also specify things like, for example, legend text. And if you're working with ggplot2, you need to specify here that you're working with the text. So element text is here. The option, and then within the brackets you specify things like, for example, size. Let's say, for example, 11. When we talk about the size here, this is mostly size that you can, let's say, encounter if you're working in a Word document. So I would say that would be kind of the comparison with. You can also specify, let's say, color also. You can also do it descriptively, like this one is a charcoal gray. Or you can also, go and look for hex code and then pass it also to R. So that's also possible. Apart from the legend title, you can also specify legends or legend text. You can specify legend title. You can make it bigger as well. Then you can also specify, I don't know, like plot title, for example, where we can actually, say something about, about this, map, what it is about. Again, you can specify the size, for example, a bit bigger, 18. You can also specify the color. Here we can use something that's gonna also have the same color as, let's say, those data points, so like dark violet. I opted for that one. It goes also well against, gray backgrounds. And also there's an option which is called HJust. This one you use if you wanna push your title left or right. So if you want it to be left justified, you take 0. If you want it to be middle, 0.5. If you want it to right justified, you put 1. So you understand it. You're like moving on a continuum where 0 is left justified, 1 is right justified, and 0.5 is in the middle. I usually put it here in the middle. There is also an option VJust, which is vertical justification, where you can push it, up or down. So again, here 0 is something which is at the top, and then 0.5 middle of the plot, and then 1 would be bottom of the plot. Apart from that, you can also specify things like also subtitle and also caption. For us, we can use the caption part where we can declare our data source, Also, this can be smaller, and also it can be in, let's say, a gray 30, so lighter gray format. And then finally, here what you can also do, because we are putting here legend on the right hand side, I would like to create some space on the right hand side and shrink everything around that. So there is a very cool option in ggplot2, which is called plot margin, where you actually can define what you actually want to, how you want to shrink things. So for that, you use units, arguments, and then here you specify in a list size of the world that you want to shrink or expand. So for example, top side, we're going to shrink, bottom side, we're going to also shrink, then left side, right side, we said we're going to add some more space, so that would be, let's say, 2. So in other words, if you want to shrink space, you put negative values. If you want to expand, you put positive, and if you don't want anything changed, you can just put 0. And then the left-hand side, we can add some space also, that's, let's say, 0.1. And here you can also specify what are the units you're working with, millimeters, centimeters, inches, or lines that I also like to use. And yeah, so this would be actually then the function. This would be the customization of our plot that we can then pass to all other plots that we create. Yeah, are there any questions now at this point? This is simply customization of the plot that we're going to then apply to every single plot. We're still not kind of plotting, we're just still preparing.
Sorry, I missed that. Did you ask something?
I asked if there are any, so if there are any questions about the, code.
Any questions so far? This is like really, like, this is not easy. Can you really follow this? There are a lot of nodes, so okay.
Interesting.
Yeah.
Yeah, this is definitely not easy. I mean, this is a bit abstract at this point because you don't really see still the effects of what we are doing here. But we will move now to the part where you will finally see what this, what this theme means that we just created. Let's start with a very, very simple plot. So let's simply plot those civilian death points without even creating any map. So this is going to be the basic ggplots. And here, what you want to do, because your main aesthetic is going to be the points, you want to declare here the data. So this is the data that we just created, UCDP GED Ukraine. It's a data frame. So we can use, for the geom, we can use points. So geom points to chart out those points. And since this is our main and only layer, we need to specify here aesthetics. So this AES stands for aesthetic. The function then defines the main layer. Because points have coordinates, we need to define X and Y. X, of course, it's always called longitude. And if you remember from the names of the data frame, X is indeed a longitude. Sometimes it can be just long or longe. And Y is latitude. And then finally here, if we want, let's say, to map based on the size of the civilian deaths, and this is what we want to present, you use size here. And then the name of that one is deaths civilians. Okay, and then here we can, so we can make this simple, just add this theme that we created, which is called theme for the win. Then we can just run this. We're gonna, could not find function plot title. Interesting. Let's see if I actually got the tidyverse here. Yeah, should be. Plot title. Oh, I see the problem. I didn't declare here that it's element text. So also for the caption. Okay, that's something to actually really be aware of, that anytime you want to declare something related to text, whether it's a title or text, you need to do this element. This is actually what I said, but then I didn't actually follow what I said. Let's actually run it again, this one. Okay, so this is the basic plot. So here, first of all, we don't even see the legend because it's on the sides, but we can fix that later. We see the data points. So this is civilian violence against civilians in Ukraine, but we don't actually see any kind of a geographic limits. We don't know where this happened. We don't know if there are no labels. There are no names of locations. So that's something that we should actually add as a part of the next step. So was this actually clear for you? Did you understand what we did here? This is a very, very simple one. So basically just, creating data points.
Yes, question.
Sorry for interruption. I have already, I was able to run the function P for the bin, but the art cannot save as object, so that's why I cannot run the ggplot function.
I have to look this. I have to look at the code. Let me see. Okay. So, Miloš, can you go back to the codes? I think we have one person who couldn't just copy the entire code entirely. There's probably missing something in that code. So have a look at this somewhere. Something may not be there.
Legend position, right? Text.
Yeah. Just give us 1 minute. Just 1 minute. Because this code is like iterative, so you do something, then use that for the next step, and then use that for the next step. So it's important that we have all these building blocks.
Yeah, absolutely.
It's good. Okay, we're fine now.
Cool. Okay, so were you able to create this very, very simple, it's not even a map, like a plot?
So can you see this plot? It's not a map yet. It's okay because we don't have the background layer. So you're just basically seeing these dots. Can you see these dots? Okay, let's continue.
Perfect. Okay, so as we said, there's not much going on here. We don't understand where these points are positioned. So we can add more. We can add an additional layer here. So we can add administrative layer. So we can add Ukrainian regions, for example. So this is sub-state level, so that we at least know a bit better, where this is taking place, and we also have Ukrainian borders. So for that, we can take global administrative borders from geodata. Geodata has this nice function which is called GADM, which is a global service for storing these different national or subnational borders. So we can use this, and then we can declare a country here that we want. Here they're finally working with ISO 3 codes in letters, and for Ukraine that's UKR. So we define that. And then we define level that we want. So as we said, we want regions. So this is the next level below the national level. You can also specify other levels if that country has. So 2, 3, 4, or 5. So these are lower and lower levels, administrative levels. So they can go from region to sub-region to municipality, village, whatever it has. Really depends on the country. So this is determined by the level. And because we want the next level, we choose level 1. So this is the level of regions. This is the biggest sub-state actually level for any country. And then for the path, we actually want to set that main working directory that we have. So we can here, for example, declare that our main working directory is going to be called main dir, this one. And we can just pass it here to the path. So this is simply for the geodata to know where to store this. And finally, we can pass this to a new object, which we can call Ukraine ADM1. And then we can just run this. So the whole thing. Okay, one thing that I want to check here is what is the class of this Ukraine ADM1, because I want it to be SF objects, but I'm not sure if it is. I didn't actually check the documentation. Well, it says it's a spat vector from Terra. You don't need to understand what it means, but what is important for us, this is not an SF object, simple features object, which we want to use for dealing with shapefiles, because this is a shapefile. So there is then a very convenient function in the SF package to convert this into a SF object, which is called st as sf. So if you run this whole thing again, and then we check the class, we finally have here that this is an SF object. So how this actually looks like, what is the SF object? So SF object has actually all the features as a normal data frame. So it has all these columns that you can imagine. But there's also this geometry field, which sets it apart from the data frame. So this means that it has certain, geo features, geometric features. So it can be a point, it can be a line, it can be a polygon. And in our case, we're dealing with polygons because obviously regions are polygons. So they need to be enclosed and to have, that dimension. One thing that you can also notice here is, what is the bounding box? So what is the, how big is a rectangle around that defines Ukraine? And you can also here see coordinates reference system. So this is a standard one. Most of the time you want your objects also to be in this form. So WGS84, you should aim for that. Okay, so that's actually how we fetch. So very easily you can do it for any country in the world. You can also do here, if you just want a Ukraine, national map of Ukraine, you can specify level 0 here. But I'm going to show you another way, another trick to actually create Ukraine based on what we have here. So there is a function in SF that we can use. So was this clear so far? So this is what you need to get. Let me actually quickly show you what you need to get if you did this correctly. Ukraine ADM1. So this is what you should be getting. This is the map of regions. Ukraine.
Let's wait for a minute so that they get it. Okay, we have a question.
No, I have problems installing the SF package.
Yeah,
So,
I don't,
so did you not install it in the beginning?
Oh, I did. I tried several ways, but it just isn't working. So right now, opening, using it means from now on to
I think there's a temporary problem with the SF package because I tried yesterday when running the code, it worked fine, but we have several people who have trouble installing the SF package, I think.
So I guess there was an alternative way to upload, because I remember several months ago I had the same problem when searching for it.
Okay, so give us 1 minute so that we solve this SF problem. There seems to be a problem with the SF package.
If you're using Mac, it's a bit difficult also to install the SF package. I know I had to install also GDAL and I think something else as well. But if you're using just, if you're using it on Windows, it's way easier. Of course, if the service is available.
Okay, let us fix that problem just a moment.
Yeah.
level 1 is not three.
So is level 1 NUTS 3 level or NUTS 2?
No, so these are official administrative borders. NUTS is simply statistical, but this is official political, let's say, subnational boundaries.
Okay. How did we solve it a couple of months ago in class? Because we use SF, right?
Yeah. I'm just trying to increase the timeout period. Because after 60 seconds it stops downloading, so maybe we can. My packages are all gone, so I'm just downloading it again.
Okay.
So it's
Is it a difference between Mac and PC, or did just SF change everything? On me, it's already installed, so I have no problem, but because the rest of this code requires simple features.
Yeah. You can also try to, remove it manually. So basically delete it from your R library and then download it actually manually. And if it's possible, and then just like put it there into your R library.
But so when you use the first part of this code, when I was giving you the list of packages you need to download, it downloaded, right?
no jump. It gave an error for me.
Why didn't you tell me?
I was trying to solve it, and I was just thinking like until we come.
So the first part of the code before Miloš started, I gave you a code in terms of which packages you need to download. Could you download all of those?
Yeah.
So it didn't give any problem when you were actually downloading the SF package, except. So you already have SF installed, but you can't use it, right?
For me,
Maybe you need some package, maybe must SF, maybe you need to remove some package.
Yes.
You have to remove ggmap, for example. ggmap sometimes masks the SF.
So yes, sometimes ggmap masks the functions of SF, so.
still,
For the package,
Yeah.
you can download the file from the current and you can install the package manually.
So we have several art experts in class, so they're trying to solve the problem.
Cool.
yeah, it's not working. I just increased the timeout period. For me, it's the download. After 60 seconds, it gives an error because of timeout.
Yeah, I also have the error for geo data as well. So if you like increase the timeout, use it.
So on WhatsApp group, tell people how you increase time.
Posted one to one.
Oh yeah, no.
So.
Yeah,
Still does not work, John. It's not about that. Okay, it's just gave a late error.
Okay. So there is an options timeout command. Then you install. Okay. I think it's just like some packages overlapping, commands overlapping in some people's. I had no problem yesterday when running these codes, but then again, I already had all these packages on my computer working. So probably it's about So maybe we can take like a 15-minute break where you can just rest and then people can solve this problem. And then can we continue? Right now it's just 11. Continue at 11. Good.
Okay, so when should we continue?
So 11:15. 15 minutes.
11:15.
Yeah, I'm pausing the recording, so we take a break.
Okay.
This problem, and we continue.
Okay.
Okay, thank you so much.
Actually,
Yeah, I'd say let's just give them another minute so that they come back to their seats. Just a moment. I'll tell you when to start. So for the record, since this is being recorded, the problem with the SF and Terra packages was when you're teaching this to large classes, a lot of people trying to download that at the same time, they run into problems with SF and Terra packages. So if you run into a problem when downloading those packages, most of the time it's an issue of internet. So we solve this by increasing the timeout duration. So something like that. Okay, let's continue, guys.
okay, hopefully we'll be able now to follow. If not, you know, we can just learn from the code itself. So we downloaded this administrative level 1 boundaries of Ukraine, and we also converted it into a simple feature subject. So we can now actually pass it to web plots that we previously created, which was actually a very, very simple one. So we can also like copy this one here. And because I would like this one to also save locally, I'm just going to put here plot 1 or P1, and then we can work off this thing. So one thing that I would like to change that I know from the previous plots we had is I would like to actually remove those cases where the civilian deaths are 0. So I don't want to show them on the map because they don't really have any value. So one thing that you can do here is when we specify the data, you can actually use the subset function from base R. And then within the subset, you can specify what you are actually, what is the column that you want to filter. So in our case is deaths civilians, and we don't want 0, so we want to remove them. So in R, but also like in SQL, it follows this pattern. So this is the sign where you say you don't want to include, or basically you want to exclude, and then everything that is 0. So that's the first step that we're going to do here. Then we move on to actually the points themselves. So we can actually, these are the things that we need to keep. So the points, point coordinates, and also the size. But what we can also add here is a bit of a, you know, color, and we can use the color that we previously created with that dark violet, I think. Yeah. Now we also have those boundaries that we want to incorporate, and if you're working with SF objects in ggplot2, you definitely need to use geom SF in order to plot this as a layer in ggplot. The way it works is pretty much the same as every geom, so you need to specify the data. In our case, Ukraine ADM1 is the data. This layer is not going to be presented as the main layer. So it is going to be there, but it's not going to have a statics field, in other words. One thing that we can do is, so polygons have, you know, are there 2D, so you can actually color their boundaries, but you can also color the interior of every polygon. But because we would like those points to be visible, we want interior to be transparent. So to do that, you can specify the fill argument is as transparent. This is what you can do. If, however, you want to put this into a different color, you can choose, like, color here. You can specify the same way we did here. But again, your points probably are not going to be visible unless you play with the transparency levels. So for now, it's simply safe to do this. Simply make it transparent. But that doesn't mean that we cannot define the borders of this polygon. So to define the exterior, so the borders, you use colors. And for color, we can, for example, use, let's say, black, so that it stands out. And also what you can do, you can specify the thickness of your regional boundaries. And this is handled by the size argument. Now the size, the more you increase it, the thicker it gets. So we want to be, it's a bit, like slick, to be, crisp. So I like to keep it around 0, this value. So let's say 0.15 in this case. But you can definitely experiment with this one and see, what it works for you. Then, because here we have the size, you remember in the previous plots, we didn't really specify, what is going to be the size of those points, and they ended up being more or less the same. So I didn't really see, the difference there. There's one cool thing about ggplot is you can specify using the scale arguments. You can specify based on your main aesthetic. In our case, this is size. You can specify, customize actually that aesthetic. So in this case, it's scale size. Sometimes you might have, within the aesthetics here, you might have color or fill arguments. So then you specify here scale fill manual or scale fill gradient or scale color. But in our case, it's the size. Here, you can then specify the range of the values for the size of your points. So if you specify here 0, basically it's not going to be visible at all. So I like to start with 1. And then the upper boundary, which is the second part of this list, can be basically anything. But I found that something around 10 is still kind of fine. I mean, this is going to be exaggerated, the size, but sometimes it's good simply to put things into perspective, to know what are the data points that are really like extremely, high. Here you can also specify if you want the name of your legends. So you can here do name, and you can even do like, let's say, civilian S or something like that. But I mean, it's not needed because we will have it in the title as well. So this is how you actually can customize the size based on this aesthetic. So we already have this theme for the wind. And then finally, we can also specify some of the labels on our plots. So as we said, we want to have a title. So it's pretty straightforward. Within labs, you can specify title equals to, and then we can say, for example, civilian deaths in Ukraine in 2022 or whatever, something like that. We also specify the caption, so we can keep this one for, let's say, specifying the data. Notice how here I wrap up everything in these quotes because this is going to be a string type. So we can go and specify UCDP, georeferenced, events, data sets. We could also put the version, but it's not really necessary at this point. So this would be the code for the plots. And then finally, we can also save this locally so that you can have your own copy if of course SF works in your case. So the first thing you define here is the name of your file. What is going to be the name? We can put, let's say, map1, and then you specify the extension. I like to work with PNG files, but R also supports JPG and some other formats, TIFF, for example, as well. The second thing you specify here is the name of the ggplot object that you're saving. In our case, it's called P1. So you just put it here. And then you can customize some things, for example, the size of your plot, so width and also height. Now, I like to work with inches, which is odd enough because I come from a metric system, but I started using inches when I started working with ggplot. That's how it is. But you can use units here, and you can specify also centimeters if you want, millimeters, even pixels. So pixels would be px. So inches are by default. I put here these units just for you to know the way you can change this. And then because Ukraine is a bit longer, width should be also, you know, greater than the height. So let's go, for example, for 9 and 6. I already check, of course, how this looks like. Oftentimes, I spend a lot of time on this ggsafe, basically figuring out, okay, what is the good dimensions, how the plot looks like, and whether I can shrink some space in between. And also one thing that I also put here is the background. So BG means the color of the background, and I pass white, but you can also do anything else that you want with the background. You can play with this. So just to reiterate here what we did, we first of all use for the main layer that data frame with the points. We removed cases or rows where the civilian depths are 0. Then we plotted our main layer, which are the points. Then we added that polygon with the regional boundaries of Ukraine. We made it transparent, but we put those boundaries into lines into black. Then we also customize the size of the points that we want to see from the lower value, which is 1, to the upper limit, which is 10. We also added our theme, our cool theme. We finally specified also the labels for our plot, so the title and the caption. So then you can simply just run the whole thing, and we can see if actually this worked for you and if you were able to produce this plot. So let me just quickly show you like what you should get if you did this right. I'm not sure actually if, yeah, so in my case, it got a bit, it cut off, but we can actually change those things. We can change the margins of our plots, but yeah, it should have also showed, you know, the title here up. But now what you can see is you can finally see the regional boundaries of Ukraine. You can clearly see now the concentration of the civilian deaths, you know, per region, and also some of them stand out, like for example, this one here in the lower right corner. First of all, let's see if you were actually able to run this, if it actually works for you, and then we can fix also this part about the margins, for margins.
Okay, let's wait. We have some nodes, positive nodes.
Cool.
But the lower number of nodes compared to previous instance. So the amount of people that are nodding are in decline. But it's okay. I mean, we had the Wi-Fi problem with SF and Terra anyway. So, but I think we have people who have done it correctly. So the rest, those of you who couldn't, can just you know, cheat and copy from them in case you run into a problem. But we can continue, I think.
Yeah, so I just want to see why we actually got the plot we got. I wonder here what actually happened. So so we decreased the top and the bottom. I guess the problem is decreasing the top. So maybe we should just put to, you know, like 0 or something. Bottom is fine, decreasing. And then we added a bit more space to the right, but we still couldn't see the, you know, the plot. Maybe we can just add, you know, some more. And on the left-hand side, I think it's fine to be 0.1. But yeah, sometimes like what usually happens when I plot is these things I actually need to go over and over and see, you know, okay, what's going on, why I can't see something. So if, for example, I change this, so if I, you know, put top to 0 and then bottom I keep the same, and I give you more space to the right-hand side, and run this. Let's see if it's gonna improve at all. Yesterday, for example, when I was running, it was fine, but yeah. So let's run again. Okay, this is actually much better because now you can see also the title. You can see the title, you can see the rest of the regions in the north, and also you can see the legends finally. So that's actually pretty cool. This is what we have, but what we don't currently have, okay, now it's fine, we actually situate into regions, but I personally, I don't know the regions that well. I mean, I know the eastern regions, Crimea and, you know, Kiev and Odessa, but, you know, most people, they don't know. So perhaps what is also good is adding labels of some of the major towns in Ukraine. That would really help us also get the sense, you know, what's going on here. And for that, we can actually use, so there is a very nice package with the, there's a package with the city, world cities for every country. So what we can do here is we can also use that package to label those cities. So that's the package maps that you hopefully installed. And that one has data, which is called a dataset, which is called world cities. So world.cities. So if you already called the library, if it's there, if you loaded it, the way you get this dataset is simply by calling this data and then in the brackets world cities. And then we can simply take Ukraine cities. So we can work with this data frame and we can build pipe here. And we can filter only Ukraine. So again, we use dplyr, filter, and then there is a field. So maybe it's good actually to export this data set so that we know what we're working with. So let's actually take the first few values of this one, world cities, so that we see what are the columns. Okay, so this is how it goes. So we have the name, we have the country, so it's a full country name. Unfortunately, I prefer to work with standard, you know, ISO codes. Then there is also info on population, and there is latitude and longitude. So actually, it's really cool that we have also this population part, because we can use it then to kind of take only the major cities. So now that we have this, I think what will be also good is check what is the name of Ukraine here. I hope it's Ukraine. I hope they didn't, you know, mess things up. So we can check this country.etc and go for the unique values of the countries, the same way we did for the UCDP dataset. So nothing crazy here. So there are a bunch of here, you know, country names. Ukraine. Can we actually? Oh, it's here. So it is Ukraine. So they didn't do anything crazy. Okay. So we can just continue with our work here. So in this filter, we can say, okay, we want only Ukraine. So country.etc equals Ukraine. So this is going to give us all the towns in Ukraine, but I mean, imagine plotting like hundreds of towns on the map. It's going to be very messy. So as I said, let's take only, let's say, top 15 towns in Ukraine, ordered by their size. And dplyr has a really cool function for that. It's called slice maps, which is basically going to do this for you. It's going to only take those top 15 based on the column that you specify. So because I want by population, I just say here, please give me the most populous cities, and then I want them to be 15 of those towns or cities. Okay, so if we now run this, and we can now also inspect Ukraine cities. I'm just gonna increase again put up the terminal. So we get 15 cities ordered by their size. Of course, Kiev is the first, and then Sevastopol is the last one. So this is ordered by the size. You can, of course, increase or decrease the number of them. That's great. And that's also up to you. But what is also useful here is that we have latitude and longitude. So this is going to allow us to actually plot this in our map. So let's work off what we already have here in this P1. So let's just copy this whole thing, including the ggSave. Now, but before we do anything on ggplot, you don't need asset package for this, but you do need maps. Were you able to actually do this slicing and dicing with World Cities data frame?
Sorry, what was the question? I missed.
So the question is, were you able to select only the 15 most populous towns in Ukraine.
Okay, checking for nodes again. Were you able to do, okay, question, yeah, ask.
World cities is already available, world of the world cities.
It's in the maps package.
Oh.
Yeah. Shash, do you want to wait? I mean, we don't have much time, but do you want to, like, 1 minute waiting? No, I think they're fine.
Cool. Okay, so now that we have this Ukraine cities, we can plug them into this next plot. So let's call it P2 because I would like to say it again. So I'm here doing this thing, but what you ideally should do, if your functions are repeating like this, you should simply create a new object and just call it. So this is not a good practice what I'm doing here, but yeah, let's just stick with it. What I would do, I would create just a new object and just apply this and just get rid of those rows where the civilian does equals 0. Nevertheless, we can do some stuff here. So as I said, one of the things that we can do here is we can definitely add those points with city names. So that's the first thing that we can do. So first of all, let's add them as points on the map. Let's add them as black points on the map so that we know, what's going on. So first of all, it's not going to be geom_sf, it's going to be geom_point because we are working with the data frame here. And then the data for this is Ukraine cities. All right. So that's the first thing. Then, because this is going to be an additional layer that is going to be a variable, so not constant, we also need to add aesthetics for those points. So X is going to be long. Well, I hope it's long, actually, not long. Yeah, it's long. Okay, so long, and Y is lat. And then here we don't want anything else within aesthetics. This will create a point, of course. You can, of course, change the size based on the population size, but we don't want to go for that. We can just specify a fixed point for the location. Let's say it's 1. And as we said, we can just color it to black so this stands out. Okay. A more important thing here is to label them. And for that, we can use the package, which is called ggrepeal. ggplot2 has, or there is within ggplot2 an option to do geom text. But I find it's not always so good because it leads to overlapping text. What ggrepeal does for you with geom text repel function, it repels them, it pushes them away so that they don't overlap with each other. And it's a pretty useful function that I found so far. So we can use ggrepeal. You probably noticed that I'm using this double column all the time. This is simply showing you from which package a certain function comes so that you know what's going on. I think it's a really good practice also to do that. So geom text repel, and there is also geom label repel. I can actually also show you what's the difference between those two. Simply, it's whether you're just going to put a plain text or you're going to put like a box and within the box a text. So label is the one with the box and text is just the plain text. So again, we use for data Ukraine cities. And again, we need to specify aesthetics because we are adding text here, right? So we need to specify the x coordinates, which is going to be long, and we need to specify the y coordinate, which is lat. But in addition to the previous one, where we just simply put the location points, we need to also specify a label here. So this is what we're going to use. And if we go back to this datasets, well, it's not visible here, but the name of the city is just called name. Okay, so that's some of the things that you can do. Now, outside of this aesthetics, we can also specify some things that are going to be constant. For example, the size of the fonts. I found 3 to be kind of fine. It's visible enough, but it's not too big. So then it overlaps with different things. For color, we can, for example, go for charcoal gray. It can be anything else. You can play with it as you wish.
Now, there is, as I said, there is one part which is really cool about this, which is that you can repel text, you can move it away. And this is managed by this force argument. So the higher the force argument here, the more they're repelled, like pushed away from their initial points in space. So let's, for example, take 5 here. You can also increase or lower this. And then what you can also do here is you can determine how far away they're going to be. So force actually makes it possible to move it away from the original point, but you can also link them with a certain line to that initial point. So this is something that you can manage by segment.size, you know, how long this line is going to be, or, you know, how short it's going to be. The longer this line, the greater this number, the longer the line from that point is going to be. And of course, you can also push it in space. You can move it along the longitude or latitude values. And for that, you can use this nudge X or Y, simply like nudging it, right? Pushing it into a certain direction. So if you choose this one, this is gonna move it, you know, in a negative direction. And then you can, of course, specify what direction this is going to be. So if I, for example, say that I want to push it southwards, this is going to be nudge Y. Why is it southwards? Because it's negative. As we said at the beginning, south is always negative, as well as west for the X value. And then for the direction, you need to specify here a different one from the nudge here. So if nudge is Y, then your direction should be X. Force, we already specified. There is also a very cool thing. Your lines don't always need to be, you know, like under 90% angle. But of course, this is something that ggRepel will also calculate. So it's a curvature argument. So here you can specify the angle under which you want to have your lines plotted. So for example, 0.6 would be 60 degree angle. Minus 0.6, you know, it's going to be minus 60 degree angle. So there are different options here that you can also use. This part is actually a bit longer, and this one is, you know, subject to also customization based on your, you know, on your preferences. And also there are a lot of other options within this geotext repel. I'm just here showing some of them here. Maybe it makes things more complicated, but on the map, it does make it kind of a less cluttered. Okay, so we now have more or less this code, but one thing that I want to change is, for example, the way we plot here civilian depths. So we're going to plot a location. It's going to be a solid point. So I would like, you know, these civilian depths to differ, not also in color, but maybe also in the way they're presented. For example, what if I only want to plot the edges and I don't want to fill the points with the color? Well, for that, we cannot really operate with the base shape. So the base shape in this case is 1. So that's just like a round circle. You need to go and choose a different shape. And this is managed by shape argument. So for that, you need actually to go and, you know, check this shape. What are the different shapes that exist? Well, here there is some explanation, but it's not actually perfect. I like to just go online and, you know, go for R shapes. And here you can see some of the shapes that exist there and their definitions. So perhaps they were also updated at some points, but the shape that I want to use here is 25. It's not really a triangle. It refers actually to the circle. And it allows me, if I use here shape 25, it allows me only to paint the edges of a point, only that. And because you probably noticed in the previous one, we have a lot of points that are cluttered together because we didn't really aggregate by location. We can manipulate the transparency of the points using this alpha. Alpha goes from 0 to 1. 0 is basically, you know, no visibility at all, so full transparency, and 1 is full visibility. So let's, for example, choose 0.75 or so. Okay, so we now defined the data. the main point layer. We also have here this, GeoMSF layer. We don't need to change actually nothing about this one. We also added the labels now with some, modifications that you probably at this point don't understand what's going on, but we will see that in a moment. And we also added, point locations. So these are fixed locations that we just want to, see what are the towns there. We also have still the scale size, which is going to customize the size of the points. And we also have the theme and the labels. And here we can also change from map 1 to map 2. And then we can proceed and actually save this. But perhaps the best thing is just to run this and then save the plot, and then we can then discuss if this works for you or not. So this is not the map, but yeah, for some reason it did give me triangles, which is pretty weird, because yesterday when I was running, it was actually circles. Weird.
For me as well. So maybe like when I tested, I also got circles. Maybe there's always like some small like change in code when you're teaching live. There's always like something that is weird. So it's okay. Triangles look good as well.
This is basically what you should get, like what I got yesterday when I was coding this. Simply the difference is in the shape. So if we just go back to what I actually got here, it's pretty much the same except for the shape of here. So it gave me triangles, but it should be circles. We can change that, we can see what's going on, but the main point here is that we now have the labels. Okay, so labels in this case, as you can see, we push them southwards. And, the thing is, we did specify also the angle, which is 60 degrees, but ggRepel in this case has a lot of also freedom, so it shows how it's going to order them. Of course, they're still overlapping with the data points, but they're not overlapping among themselves. This could also be like further customized. Of course, you can push them in different directions. You could push, for example, certain towns in certain directions. You can really play with this. But yeah, this is more or less how you add labels to your plots. I do wonder what happened, but we don't have much time. I wanted to show you one more thing, before we take off. I'm just wondering if those of you who have the SF package, were you able to run this at all?
Any problems so far? Do you want us to like take a 2-minute break or like a 1-minute gap? No. You're like machines. I really like that. Like, okay, fine. I mean, they're okay. They want to continue.
Great. Okay, so the last part is how do we add some kind of a street layers, let's say from Google Maps or OpenStreetMaps, if we don't really like the way we did the labels, or maybe we want more context. We want also, let's say, terrain in the background. So luckily for us, ggmap is there, and it can offer us a layer, street layer or terrain layer, whatever you can imagine, from different services, Google Maps, OpenStreetMaps. And for that purpose, we need to pass to it a bounding box of our Ukraine plot. So the first thing is, of course, better be is to not use those regions. Better be to provide a national map of Ukraine. So now I will show you how you can actually do that pretty easily, just using SF. Of course, if you have SF. So you can use from SF ST union. What this is going to do is collapse all those substate polygons that exist and just give you like a single polygon of Ukrainian national boundaries. So here we pass this one Ukraine ADM1, and we can just run this. And this should create the national boundary of Ukraine. So if I inspect this, that's the geometry, and then inspect Ukraine. So this should give, yeah, it does. So we just got the national map of Ukraine. So basically all those polygons were collapsed into the highest possible level, which in this case is the national boundary of Ukraine. So only the most outmost outer boundaries were taken in this case. Of course, you can also use that service from geodata and just specify the level, but sometimes you just want to, do these things. Now, in order for ggmap to know what is the area for which we need this, we need to pass it a bounding box. So bounding box is simply, if you go to this, again, to this map of Ukraine, what the bounding box would be is something like this rectangle that you have here, but it would be basically wrapped around the boundaries so that basically it just touches the most extreme points on the left, right, top, and bottom. And the bounding box is often used to download satellite data based on a certain region. So that's what you provide. And bounding box in specific or in simple terms is a rectangle that has minimum and maximum longitude and latitude values for the area that you're looking for. And again, asset package also offers the possibility to create a bounding box. So for Ukraine, we can also do that by using stdbox argument from asset package, and we just create a bounding box based on this Ukraine, simple features object. So how does this look like? What is this bounding box? Well, for one, bounding box is not a polygon or anything. It's simply this, table that you can see here with this kind of a 4 columns, or more like a vector, where you have x-min stands for minimum longitude, y-min for minimum latitude, and then you have maximum longitude and maximum latitude. Exactly what I said. So this is in WGS84 format that we used at the beginning. So what we need here, we need to extract those coordinates and put them into a list so that ggmap knows what actually should download for us. So we need to grab from this Ukraine VBox, we need to grab, first of all, the first element of that vector, which is minimum longitude values. Once we do that, we should grab in this order again, minimum latitude values or y-min, and then the last two are simply the maximum values for the longitude and the latitude. So we are doing this only because this is about the formatting thing. So how ggmap accepts this bounding box values so that you can actually get a map for us. So this is how you do it, and then it's nothing special. So basically, what it does, it just puts everything into a single list here. So once you have these coordinates, we can create our also Ukraine layer, and we can call ggmap, which has several ways of getting things. So you can get Google Maps. I don't use this one because for some of the layers that I want to download, you need access to the API. So you need your username and password. So I just go for statement maps from OpenStreetMaps, which offer more flexibility and I would say greater, more like options, more layers that you can download. So here we pass Ukraine coords that we created before. And then we specify the zoom level. So the higher the zoom, the more details you have, but it also takes more time for the ggmap to return to you all the tiles it needs in a single format. So I went here for 7. You can explore, but with 8, it already gets a very too much for it. And then the fun part is the map type arguments. Here you can specify what are types of maps that you want to download. So here you can see, or I hope you can see the box here. So there are different types. You can do terrain, terrain flat with labels. You can do simple ones, so just like grayscale. You can like really explore with this. There are a lot of things, but for this purpose, we can just simply use terrain. So we can then run this. So here you can see that it's working. It says that it's accessing map tiles from OpenStreetMaps, and it's done. So if you want to quickly inspect how this looks like, you again need to use this ggmap option. So ggmap, and then we can pass Ukraine layer to it. So let's simply just plot this. So this is what we got. So this is according to the bounding box that we provided. So basically it gives us Ukraine and the neighboring countries that fit into that bounding box. The level of detail here is better than what we had with simply labels, because we have both the names of the regions and the major towns. We also have topography, including the lakes and some rivers. And we also have some of the roads. I don't know if you can see that, but they're here in white. So it offers more, more detail. So what you can do, we can simply pass this to ggplot2 and then create, a cool map. And what we can do is we can simply work with maybe not the P2 object. We can maybe work with P1. P2 is quite long, and we are not going to use labels again. So we can just copy the P1 here and paste it here, and then change this. Let's call it map 3. Okay. So one thing to remember here is when you're using ggmaps, you should specify here ggmap rather than ggplots. And here you should just specify then Ukraine layer. So you're just calling it, this is going to be your base layer. Now that has some also repercussions for the way you're handling things. And one of them is, because this is going to be the main layer now, you want to make sure that you allow other layers to be added. And the way you do that is using inherit.aes equals false. Basically, that means that you're not going to inherit, that you're not going to superimpose just this layer and then this allow other layers to be plotted on top. This means you're going to allow also points to be added to this main Ukrainian layer. This is the main thing. But now, because we pruned the data source from this main plot, we need to specify here within the geom points. And here it comes back to bite me that I didn't subset that data, so I need to do it again. So I need to subset that UCDP GD Ukraine and the civilian that are not 0, we will include them. Okay, so yeah, I think I know what is the problem. The problem is not 25. Maybe it should be the shape 21 here. So if we go, we can try shape 21. It should give us what we are looking for, to only paint those edges of the points. I think that might be the problem, but let's see. And again, we can also stick to that alpha 0.75 to allow other points to be also visible. Yeah, so at this point, we don't really need this GMSF, this Ukrainian administrative level 1 borders, because we already have them here. Maybe they're not so visible. One thing that you will notice once you print this against this layer is that they don't really correspond with those downloaded for OpenStreetMap. So we can just remove them for now. Are there any other things that we want here? Probably not. So we can go ahead and print this and see what is the resulting plot. Okay, let's see, map 3. Okay, so yeah, instead of 25, it should be 21, definitely. So we now got exactly what we need. We got circles with only borders painted, but not the interior. And this offers better visibility, because now you can clearly see regions and also towns and also topography, which can also be interesting. yeah, what you could also do, perhaps, if this is not visible, or if it's like goes against the, you know, some color values, it doesn't blend well, you can also go for the grayscale version of this layer as well. It's a pity we don't have much time left, because I also wanted to show you like some more advanced geospatial techniques where you can actually do even some analysis and see, you know, what is the percentage of deaths per region. But you have it also here on the here in the GitHub repo that you can freely access. So you can clearly see here some other things. This is where you use when you facet these different maps per month. This is why we created that month column to start with. And this is what I was telling you about adding information about you know, the share of civilian deaths per region, which can then offer you more information about, you know, conflict itself. Yeah, so if you have any question, you can reach out to me, but you can also check out first, you know, this small repo that I prepared for you together with plots. I will change the code to make sure that triangles don't show up, but actually that we have points in this specific plot and this one. But yeah, it was really a pleasure, you know, presenting today in front of you. I didn't do it in a long time, but I really enjoyed it, especially that I'm now kicked off also my YouTube channel. And speaking of which, I'm just gonna quickly show you. So this is my YouTube channel. It's called Miloš Makes Maps. And here you can find a lot of videos on other geospatial topics that we didn't cover here. For example, how do you do 3D maps? How do you leverage OpenStreetMap data? How do you plot topography? How do you create hexagonal maps? And also Eurostat maps, zone statistics. I mean, there are a lot of things that you can check out here and see if it works for you. There is one YouTube tutorial that I recently did. It's called Animated Bubble Maps with R. This is where I use the exactly UCDP GED data on Syria. And I show you also how you can plot civilian deaths in Syria since the start of the war. And not just that, but I also show you how you can animate, how you can create time-lapse bubble maps in this store. So do check it out. It's a bit longer, but really takes you on a journey step by step. And as it unfolds, shows you different things from data wrangling to static maps to animated maps.
Well, thank you so much. Miloš, let me try to show you the class so that you can just like see them directly. Guys, please join me applauding.
Thank you.
So basically, I think we have time for 2 quick questions if you have any questions for them. I mean, my immediate question would be this. So this group is very interested in causal inference. So how would they start learning about causal inference spatially, like spatial econometrics or spatial inference? Do you know of like any good introductory like books or pages where they can start doing like statistics with spatial data?
Yeah, I did that once or twice in some of the papers that I did before. I didn't actually go for any sources because I already knew how to you know, get the data I need. So I'm not really a good person to suggest any tutorials on that, but I bet they do exist on YouTube. If you just search, you will probably bump into something. There are people with more advanced topics. They also don't use R necessarily. They use QGIS or ArcGIS, which is more user-friendly. And it's much easier for you to also create anything you need. But you can also, so you can check my tutorials for the ways you can create the data for yourself. So how do you extract, let's say, topography information, or how do you extract, you know, population or anything else? Because that also might help you at least do some kind of a quasi-experimental analysis. I'm thinking here about differences. You could use perhaps geography and some or you can use maybe even better example of regression discontinuity design. Geography perhaps is not a good, I think, example here because it's fixed. You want something that is not determined by geography, but maybe you can use that to kind of map some patterns, and then based on that, you can decide on the way you want to design your study and the method that you want to use. I think for the causal inference itself, we didn't really cover here. This is really basic stuff, and this was mostly about how do you go about data wrangling, and how do you do some descriptive statistics, and then how do you map those statistics on the map, and what are the different ways to do that. This was simply, I would say, how you kind of can locate different patterns, how do you identify different patterns using mapping with R.
Yeah. Well, okay, one question.
I wonder why you prefer R over other like mapping tool or like Python or whatever. And I wonder you use R, but you also, and I remember you work for .com. And like, do you all use R for this, or are there people who use also Python?
Yes, so I think it's a very good question. Some of the operations I actually use, some of these geospatial operations that maybe are more complex, or I just want to have more visibility. I use QGIS, which is powered by Python actually. It offers more, sometimes it's faster, sometimes it's pretty much the same speed, but it allows me to, in this editor, to see what I'm actually doing. In R, you cannot see that unless you always check what you're doing. But the advantage of R or Python in comparison with QGIS and ArcGIS is, I would say, the ability to replicate the code, to replicate and then debug. If you're working with QGIS and ArcGIS, you can show what you're doing, but you cannot necessarily replicate everything, what's going on there. For Python, on Twitter, I do follow one guy. It's called Python Maps. Unfortunately, he doesn't share the code with other people, so you can just see his maps, what he's doing. But from what I gathered from the feedback I got on my channel, apparently there are way more YouTube channels and videos on using geospatial analysis with Python than R. So in other words, if you go there and try to search, you will definitely find. Why I use R? Simply because I started with R like 9 or 10 years ago. Nothing else. But I bet that in some cases, Python might be even faster the way it works than R, especially with regards to geospatial analysis. To what extent, I don't know, because they both rely also on, let's say, GDAL library. So they both use also some similar sources. So I don't know to what extent actually is Python more powerful. I can only speak from my experience with QGIS, which uses Python as its backend platform. Yeah.
Well, Miloš, thank you so much again. Let's give another round.
Thank you too.
Let me stop the